Everyone wants to build an AI agent or a RAG system, but almost nobody maps out the actual infrastructure making those systems possible. Say you have thousands of internal company policies. The obvious first step is to dump all those documents into a standard SQL database and let the AI assistant search through them. Here is where that approach breaks down immediately. Traditional databases are built exclusively for exact or partial text matching and look for specific keywords. If an employee asks, "How many days off do I get per year?" the word vacation might not appear anywhere in that specific phrase. The database returns nothing because it has no idea those two concepts are related. Vector databases were engineered specifically to solve this limitation. They abandon exact keyword matching entirely in favor of meaning-based matching. This table, the AI memory gap, shows exactly why this architectural choice dictates your results. On the left, traditional SQL fails on contextual questions because it relies on exact text strings. On the right, vector architecture succeeds because it calculates mathematical meaning. To eliminate hallucinations and safely deploy proprietary data, you have to leave traditional databases behind. So, how does meaning become math? Machine learning models take words, entire sentences, or even images, and convert them into long lists of numbers called vectors or embeddings. These numbers are positioned within a mathematical space. Concepts with similar meanings generate similar numbers, which groups them closely together. Looking at this 3D spatial grid, you can see how this spatial relationship works in practice. If you take the data point for king, subtract the vector for man, and add the vector for woman, the resulting coordinates land exactly on queen. When a user asks a question, that text is also converted into a vector. The database simply measures the exact distance to find the closest clustered data points, retrieving the correct documents even if the original keywords never match. Executing this mathematical proximity search across millions of documents in milliseconds is the core engine powering modern RAG systems. Before evaluating specific tools, you have to factor in the hidden cost of the system, your data ingestion and chunking pipeline. You cannot feed massive raw PDFs directly into an embedding model. A strong baseline metric for processing text is breaking it into 300 to 500 token chunks, while leaving a 50 to 100 token overlap at the boundaries. This visual shows the difference between a weak pipeline and a precise one. On the left, a fixed-size character splitter arbitrarily slices text right through the middle of sentences. On the right, semantic chunking cleanly divides the text by natural paragraph and topic breaks. If your chunks are too large, the database pulls in irrelevant noise and you lose precision. If they are too small, you strip away the contextual details the AI needs to formulate an accurate answer. A poor chunking strategy guarantees the AI will retrieve fractured context. Your choice of database will not save you from a badly prepared data pipeline. This quadrant chart maps the vector database market based on a primary trade-off: the infrastructure effort required to run the tool versus its scalability and performance. If you are a prototyper trying to validate an idea quickly, ChromaDB is your entry point. It operates entirely locally and integrates seamlessly with frameworks like LangChain and LlamaIndex. You can have a working prototype running on your laptop in under an hour. However, Chroma lacks the complex architectural features required to handle heavy production traffic. For the performance optimizer dealing with heavier loads, Qdrant enters the picture. It is open source and written in Rust, which makes it extremely memory efficient and exceptionally fast at executing semantic searches across large datasets. The trade-off for that speed is the operational burden. Your team must deploy it via Docker and manage the hosting infrastructure themselves. Both of these tools keep your data localized, but they force your engineering team to manage the hardware boundaries, trading expensive cloud subscriptions for manual development hours. If your objective is production scale and you want to avoid server maintenance entirely, Pinecone is the default option. It operates as a fully managed cloud-native API. It scales automatically to meet demand, freeing your team to focus exclusively on application logic. Adopting a managed service introduces vendor lock-in. Once your vector count climbs into the millions, those automated SaaS costs will escalate quickly. Finally, for the precision seeker navigating highly complex data, there is Weaviate. Weaviate's primary advantage is its native hybrid search architecture. Sometimes semantic meaning isn't enough. If an engineer searches for a specific part number or a lawyer queries a legal statute, hybrid search combines a vector similarity check with a traditional exact keyword match, running both simultaneously in a single query. Achieving that dual-layer accuracy introduces the highest level of architectural complexity and requires significant engineering hours spent fine-tuning query weights. Operating AI at production scale requires you to choose your cost. Either pay a premium cloud vendor to handle the heavy lifting, or invest severe engineering hours into advanced architectural tuning. Vector databases are not strictly limited to reading internal PDFs for chatbots. When Spotify surfaces an artist you instantly like, or Netflix lines up a movie recommendation, they are relying on the exact same architecture. They convert your user history into a vector and measure its distance against their massive catalog. In cybersecurity, normal network traffic clusters tightly in vector space. When an erratic action breaks away, the system instantly flags it as an anomaly. Vectors act as a universal numerical language. Investing in this infrastructure equips an organization to handle matching, recommendation, and security operations long-term. This decision flowchart narrows your options down to your actual project constraints, your budget, your timeline, and your team's technical skills. If you have zero budget and need to validate an idea immediately, use ChromaDB. If you require strict data privacy, need to control costs, and have the internal DevOps skills to self-host, run Qdrant. If you are prioritizing speed to market and demand zero server maintenance, pay for Pinecone. And if your use case demands strict nomenclature combined with semantic meaning, invest the engineering time into Weaviate. Success in the modern AI landscape is about matching the right database to your specific operational reality while rigorously executing your data preparation